All right, so you're here because you want to understand streaming architectures.
That's right.
And trust me, it's a fascinating world. It's
Yeah.
all about getting these real-time insights
Yeah.
from all the data flooding our world.
Yeah.
Kind of like having a finger on the pulse of, well, everything.
Everything, yeah.
And we're diving into a blog post today called Streaming Architectures, a deep dive,
Okay.
which does a great job of really kind of breaking down the complexities
Yeah.
to help visualize this.
Okay.
Imagine a data platform as a high-tech factory,
Okay.
constantly converting raw data into valuable insights.
Yeah, I like that analogy.
Like a factory.
Yeah, because it really highlights that shift from just storing data to actively using it
Right.
in real time. And I think companies like Netflix, for example, have really built their entire business model around this,
Exactly.
using cloud-based infrastructure to manage and analyze massive data streams.
Exactly.
Yeah.
So let's take a tour of this data platform factory, starting with the foundation,
All right.
the hardware level.
Okay.
We're talking servers here,
Right.
both physical and cloud-based. Like, Amazon EC2 for processing power and S3 for storage.
Yeah.
This is where the raw materials come in,
Yeah.
all that data pouring in from various sources.
Yeah. And just like a factory needs reliable power,
Right,
a data platform needs reliable storage.
right.
So that's where the persistence level comes in.
Okay.
Systems like HDFS or cloud services like Amazon S3 are designed to ensure that your data is safe and accessible, even if there's a hardware hiccup.
Oh, okay.
Yeah, so it's like having backup generators in case of a power outage
I see.
keeps the factory running smoothly.
Makes sense.
Yeah.
But having all this hardware is just the start, right?
Right.
We need something to manage it all,
Yeah.
to direct the flow of data and processing power.
Absolutely.
Right.
That's where the resource manager comes in.
Okay.
It acts as the brain of the operation. It allocates resources like computing power and memory,
Okay.
making sure everything runs efficiently.
All right.
And this is especially critical with these fluctuating workloads that are typical of data streaming,
Yeah.
which is why systems like Kubernetes, with its auto-scaling capabilities, are becoming so popular.
Kubernetes, Mesos, Yarn,
Yeah.
all these names you'll hear a lot
Exactly.
in the world of resource management.
Yep.
But we've got the hardware,
Yep.
the storage, the management.
Yeah.
What about the actual processing of data?
Right.
That's where things get really interesting.
Exactly.
Well,
Think
who's
of the
that?
execution engine as the heart of the factory.
Okay.
This is where the raw data is transformed into valuable insights.
Right.
We have powerful engines here like Apache Spark, Apache Flink,
Okay.
even the classic Hadoop MapReduce,
Yeah.
each with its own strength.
Right.
Spark, for instance, is like a powerful all-rounder, great for batch and micro-batch streaming, while Flink excels at true real-time low-latency processing,
I see.
which makes it ideal for applications like fraud detection.
So choosing the right engine depends on what you're trying to achieve.
Exactly.
Much like a factory chooses different machines for different tasks.
Right.
But before any of this can happen, we need to get the data into the factory in the first place.
Right.
What's that part of the process called?
That's the data ingestion component.
Okay.
It's like the receiving dock, handling that constant influx of data from various sources.
Right.
Apache Kafka is a popular tool for this,
Okay.
capable of handling incredibly high volumes of data with minimal delay. Companies like LinkedIn, which process billions of events every day,
Wow.
rely on Kafka to keep their platform running smoothly.
Billions of events a day. That's,
A lot.
it's mind-boggling.
Yeah.
Okay, so the data is in.
Yep.
It's been processed.
Right.
Now what?
Now the question is,
Where do those valuable insights go?
where do they go, right? So that's where the process data sync comes in,
Okay.
directing the refined data to its final destination.
All right.
This could be a database like Amazon Redshift for further analysis, or it could be used to trigger actions within another system,
Okay.
like automatically adjusting pricing on an e-commerce platform.
So it's like the shipping department.
Yeah, exactly.
Sending those insights out into the world to do their job.
Exactly.
But rows of data and numbers aren't exactly easy to digest,
Right.
right?
They're not.
How do we make sense of it all?
Yeah, that's where the visualization layer comes in,
Right.
transforming that raw data into understandable visuals like charts, graphs, dashboards,
Yep.
tools like Tableau, Power BI, and Grafana, which Airbnb uses for performance monitoring, by the way,
Oh, wow.
are essential for making data insights accessible and actionable.
So it's like having a showroom where we can see the final product,
Exactly.
all polished and ready to impress. All right, we've got a good understanding of the different components in our data platform factory.
Yeah.
But what about the overall architecture of these systems?
Right.
How are they designed to handle this continuous flow of data?
Yeah. That's a great question.
That seems like the next logical step in our deep dive.
Absolutely. And there are different approaches to building a streaming architecture,
Okay.
each with its own set of trade-offs and considerations. And that's precisely what we'll explore next.
Right.
Yeah. When it comes to streaming architectures, there are two prominent models that you'll frequently encounter,
Okay.
Lambda and Kappa.
Right.
Both are designed to handle this continuous influx of data, but they take different approaches.
Okay, let's break these down.
Sure.
Lambda architecture sounds intriguing.
Yep.
What's the story there?
So Lambda architecture takes a two-pronged approach,
Okay.
combining batch and stream processing. It's like having two separate production lines in our data factory.
Yep.
The batch layer handles large-scale processing of historical data,
Okay.
building that solid foundation of knowledge. Think of it as the big picture analysis.
Right.
Meanwhile, the speed layer focuses on real-time updates and insights,
Okay.
reacting quickly to the latest events as they come in.
So it's like having a historian who can analyze long-term trends
Exactly.
alongside a news reporter who's always on top of breaking news.
Yeah, great analogy.
They each bring their own expertise to the table.
Precisely.
Yeah.
And this combination can be incredibly powerful. For
Right.
instance, Netflix's recommendation system is a classic example of Lambda architecture in action.
Okay.
The batch layer analyzes your viewing history and preferences to build a detailed profile of your tastes.
Right.
Then the speed layer takes your real-time activity into account,
Okay.
what you're currently watching, browsing, or even pausing
Yeah.
to generate those eerily accurate recommendations.
That makes a lot of sense.
Yeah.
But I'm curious about Kappa architecture. How does it differ from this two-pronged approach?
So Kappa architecture aims for simplicity.
Okay.
Instead of having separate batch and speed layers, it relies solely on stream processing,
Okay.
using a single super efficient pipeline to handle everything.
All right.
Imagine it as streamlining the factory,
Okay.
consolidating those two production lines into one.
So it's like having a single high-speed conveyor belt
Yeah,
handling both the raw materials and the finished products.
exactly.
But how does Kappa deal with historical data if it's only using stream processing?
Right.
Doesn't that limit its ability to provide context?
That's a good question.
Yeah.
And that's where systems like Apache Kafka come into play.
Okay.
In Kappa architecture, you can effectively rewind and replay past events stored within the stream,
Okay.
allowing you to reprocess historical data as needed.
I see.
So it's not that Kappa ignores historical data.
Right.
It just handles it in a different way.
So it's like having a recording of the entire production process that we can revisit and analyze at any time.
Yeah. And a good example of this is LinkedIn's real-time activity tracking.
Oh.
All those likes, comments, and shares you see happening on the platform
Yeah.
are processed through a single streaming pipeline.
Mm-hmm.
This allows them to provide instant feedback and keep the platform feeling dynamic and engaging.
That's impressive.
Yeah, it's pretty cool.
It sounds like Kappa architecture really prioritizes speed and simplicity.
It does.
But are there any downsides to using only stream processing?
Yeah, that's a good point.
Are there scenarios where it might fall short?
You're right to consider the trade-offs.
Yeah.
Kappa might not be ideal for applications that require complex batch processing
Okay.
or in-depth historical analysis.
Right.
Sometimes you need that dedicated batch layer to really dig deep into the data and extract those nuanced insights.
Yeah.
For instance, imagine an e-commerce platform
Okay.
trying to identify long-term sales trends or seasonal patterns. They might need that deep dive into historical data
Okay.
that a dedicated batch layer provides.
So it's about choosing the right tool for the job.
Exactly.
Lambda for when you need both real-time insights and deep historical analysis.
Yeah.
And Kappa for speed and simplicity.
Right.
But regardless of the architecture you choose, there's another crucial element we need to consider.
What is that?
The algorithms that power these systems.
You're absolutely right. And this is where things get particularly interesting.
Okay.
Algorithms designed for streaming architectures
Yeah.
are fundamentally different from those used in traditional batch processing.
Okay. I'm intrigued what makes these streaming algorithms so unique.
Think of it this way.
Okay.
Batch algorithms have the luxury of working with complete data sets.
Mm-hmm.
They can see the whole picture,
Okay.
analyze all the data at once.
Right.
But streaming algorithms deal with a constant influx of data,
Yeah.
where information is constantly flowing in.
Right.
They have to make decisions on the fly based on the data they've seen so far without knowing what the future holds.
Right.
It's like trying to solve a puzzle while someone keeps adding new pieces.
That sounds like a real challenge.
It is.
How do these algorithms cope with this constant stream of information and still manage to make accurate decisions?
That's the ingenious part.
Okay.
Streaming algorithms are designed to adapt and learn in real time.
Mm-hmm.
They use sophisticated techniques to identify patterns,
Okay.
detect anomalies,
Right.
and make predictions, all while the data keeps pouring in.
Wow.
It's a bit like learning to dance on a moving train.
Oh.
You have to constantly adjust to the changing environment.
That's a great analogy. So they're constantly learning and adapting.
They are.
But I imagine there must be some limitations, right?
Right.
Especially when it comes to accuracy.
Yeah.
Given they're working with incomplete information.
You've hit the nail on the head.
Yeah.
One of the key trade-offs with streaming algorithms is the balance between speed and accuracy,
Okay.
because they're making decisions in real time
Mm-hmm.
based on limited data.
Right.
They may not always be as accurate as batch algorithms
Okay. Yeah.
that have the benefit of hindsight.
Right. So it's a trade-off.
It is.
Do you have any real-world examples of where this tension between speed and accuracy plays out? I'm really curious to see how these algorithms are being used in practice.
Yeah. Think about fraud detection systems.
Okay.
They can't wait for a transaction to be complete before analyzing it.
Right.
They need to flag suspicious activity in real time.
Yeah.
PayPal is a great example.
Mm.
They use streaming algorithms to constantly monitor transactions
Okay.
and identify potential fraud as it happens.
Too late.
It's like having a security guard who can spot a fake ID before the person even enters the club.
That's fascinating.
Yeah.
So they're making split-second decisions
There you go.
based on incomplete information.
Yeah.
Talk about pressure.
It's a lot of pressure.
But I imagine those algorithms are getting pretty sophisticated,
They
especially with the amount of data they have to learn from.
Right. And the more data they process,
Yeah.
the better they become at recognizing patterns and anomalies.
Makes sense.
It's a continuous learning process,
Right.
but it does highlight the inherent uncertainty in real-time decision-making.
Uncertainty is definitely a factor.
It is.
But it's remarkable how these algorithms can still be so effective.
Yeah.
I'm curious.
Yeah.
Are there any other examples where this balance between speed and accuracy is crucial?
Absolutely. Consider content moderation on social media platforms like Twitter.
Okay.
They use streaming algorithms to flag inappropriate content in real time,
Mm-hmm.
trying to prevent harmful content from going viral.
Right.
However, these algorithms might occasionally miss something,
Oh, I see.
something that would be caught later during a more thorough analysis.
So it's like
It's a constant battle against the sheer volume and speed of online content.
trying to filter a river with a small net.
Yeah, exactly.
You can catch a lot, but some things are bound to slip through.
Right.
So even with these incredibly sophisticated algorithms,
Yeah.
there's still a need for human oversight and intervention.
That's a great point.
Right.
Technology can be a powerful tool,
Mm-hmm.
but it's not a silver bullet.
Right.
We still need human judgment and critical thinking
Yeah.
to navigate the complexities of the digital world.
Well, this deep dive into streaming architectures has been incredibly eye-opening.
It has.
We've gone from the basic components of a data platform
Mm-hmm.
to the different architectural models,
Yeah.
and even explored the unique challenges of streaming algorithms.
Right.
It's amazing to see how far this technology has come.
What's even more exciting is that this is just the beginning.
Really.
Streaming architectures are becoming more accessible,
Oh, wow.
allowing businesses of all sizes to leverage real-time insights.
That's pretty cool.
It's democratizing access to powerful analytics,
Mm-hmm.
which has the potential to revolutionize entire industries.
You're right. It's no longer just the tech giants playing in this space. Imagine small businesses being able to personalize customer interactions in real time.
Yeah.
Or doctors having instant access to the latest medical research
Mhm.
to inform their diagnoses.
Absolutely.
The possibilities are truly transformative.
They are.
And this brings us back to that initial idea of having a finger on the pulse of everything.
Yeah.
Imagine a world where every interaction, every piece of data could be analyzed in real time.
It's mind-boggling.
The insights we could gain, the potential for innovation.
Yeah.
It's both exhilarating and a bit daunting,
It is.
isn't it?
Yeah.
We're on the cusp of a new era of data-driven decision-making.
Right.
But as with any powerful tool, we need to be mindful of its implications.
Absolutely. The ethical considerations around real-time data analysis are crucial. We need to ensure these technologies are used responsibly,
Right.
with respect for privacy and fairness.
Yeah.
It's a conversation that needs to happen at all levels of society.
To our listeners,
Yeah.
we hope this deep dive has sparked your curiosity and given you a better understanding of the power and potential of streaming architectures.
Right.
The world of data is constantly evolving,
It is.
and it's up to all of us to engage with these developments thoughtfully and critically.
Keep exploring, keep learning.
Yeah.
And who knows? Maybe you'll be the one pioneering the next breakthrough in streaming technology.
Until next time, keep diving deep.